let's go over the properties of logarithm. We have three properties for the common logarithm log, and then three properties for the natural logarithm ln. So starting with the log, so we have a product rule that is log base b x times y equals to log base bx plus log base by. If you change the multiplication to a division, x divided by y, then you change the plus to a minus. For a power rule is the most popular. You will be using this many times in your future math classes. Log x raised to the nth power, you can bring the n down to the front of log. This is the most popular. For natural log, we have something similar. Ln x times y, that is equals to ln x plus ln y. For ln x divided by y, we change the plus to a minus. And then the most popular one, the power rule, ln x raised to the n, you bring the n down to the front, and then once again, this is extremely popular in your future math classes. And then we have two more. Actually, they are not the properties at all. Ln x divided by ln y is not the same as ln x over y. So I want you to compare this and that. What is the difference? The first one, ln of x divided by y. So when we are talking about the procedure, like the orders, we take x divided by y first, and then we ln the quotient. In comparison, ln x divided by ln y over there, we do ln x first, and then we take the result, we calculate ln x first, then ln y next, and then we divide the result. They are not the same at all. Alright, so when you encounter ln x divided by y, or you multiply them, it is what it is. There is no way to simplify that. This also apply to the log. Okay, so for exercise, I would like you to find the exact value without using a calculator. So the first one, I have log base 6 of 36. This type of problem is not that hard to do. So here is how we do the first one. So we have log base 6 1 over 36. Let's rewrite the 1 over 36. So this is log base 6, and then 6 is 6 square, right? But you have the 6 square in the denominator. That is equals to log base 6 to the negative 2 power. Alright, and then by power rule, we can bring the negative 2 down to the front. So negative 2 times log base 6 of 6. Log base 6 of 6 is just equals to 1. So we have negative 2 times 1. The answer is equals to negative 2. But why is that equals to 1? So this is a log 6 base 6 and then 6, right? So this is equals to 1 because 6 raised to the first power is equals to 6. This 6, the base, raised to the first power is equals to 6. Alright, so let's do the fourth root. I'm going to change color for every single problem. So we have log base 2, and then this is the fourth root of 1 over 8. And then that is equals to log base 2. So the fourth root, they both share the fourth root. So we have the fourth root of 1 divided by fourth root of 8. So, and then log base 2, the top is a 1. And then the bottom, what is the bottom? 8, 2 times itself 4 times is equals to 8. Then this is equals to 2. And then since we have log x, one number over the other, that is log base 2 of 1 minus log base 2 of 2. The log base 2 of 1 is equals to 0, and then the log base 2 of 2 is equals to 1, and then therefore this is equals to negative 1. Why is this a 0? Because 2 to the 0 power is equals to 1. This one is 2 to the first power is equals to 2. Alright? Okay, moving on. Oh, log base 2. Let me just do it right over here. So we have log base 2 of 1 that is equals to 0 because 2 to the 0 power is equals to 1. Logarithmic form, exponential form. Alright, so that is the second problem. And then moving on, we have a log base 3 of negative 27. Let's switch to a different color. So we have log base 3 negative 27, and then plus log base 9 of 81. Now, is the first one possible? 3 raised to the what power is equals to negative 27. Remember, 3 is a positive. It doesn't matter how many times you multiply itself, you will never get a negative. So this is not possible. Not possible because the base is not negative. Negative, if you have a negative 3, then there might be a chance, but this is a positive, so that is not possible. And then the other one, 9 squared is equals to 81. So log base 9 of 81 is equals to 2. So this is basically you have a not possible, which is the log base 3, and then plus 2. Well, the answer is just not possible because you cannot evaluate the first one. No solution, no answer. There is no way to answer to that. And then after this problem, we still have 2 logs, right? And then we have an ln. Okay, I'm going to switch color for the next one. So the next one is log base 5, 75 minus log base 5 of 3. So this is same base 5, you have a minus, then it is okay to condense them to a single term. 75 divided by 3, so that is equals to log base 5, and then which is a 25, right? 5 raised to the what power is equals to 25, the answer is 2. This is true because 5 to the second power is equals to 25. All right, can we just evaluate that at the very beginning? I don't recommend you to do so because this one you have to think about 5 to the what power is equals to 3. That is hard. Yeah, this one is hard, right? So that one is hard. So I don't want to go this way. I want to apply the property first, make the number easy, so my job is way easier. Okay, next problem, we have a base 4 of 2, base 4 of 32. Don't worry about the problem. I will copy the problem for you. So the next problem, we have a log base 4 of 2, and then plus log base 4 of 32. All right. So this one, 4 to the what power is equals to 2. 4 to the what power is equals to 32. The way I do this is, I would write log base 4. For the 2, I am going to put it in another way. I will just do 4 to the 1/2, which is the square root of 4. And then plus log base 4. And then the 32, I will just do a 4 to the 5 over 2. Because for the half, do you see the denominator, the 2? The square root of 4 is equals to 2, and then 2 raised to the 5th power is equals to 32. And then this one, we have an exponent, so it is okay to bring this down, and also it is okay to bring this down. So we have log base 4. Oh, actually, you know what? I forgot the fraction. 1/2 times log base 4 of 4, and then plus 5 over 2 times log base 4 of 4. Why do we have to do a log base 4 of 4? The answer is simple. Log base 4 of 4, what is that equal to? That means 4 to the what power is equals to 4, and this power must be equals to 1. So therefore, we are doing a 1/2 times 1, and then plus 5 over 2 times 1, which is 6 over 2, that is equals to 3. You might ask me, hey, is this the only way to do it? The answer is no. So there is another way to do it. Do you see that there is a plus? So that is equals to log base 4, and then you can multiply them. 2 times 32. In fact, this method is faster. So log base 4, 64. So since 4 to the 3rd power is equals to 64, that means this is equals to 3. But when I force you to put that in the base 4, I train your mind, right? So this one, the blue method trains your mind, and then the red method is straightforward. We have one problem left. The problem is ln. You have 1 divided by the cube root of e. So this is equals to ln one term divided by the other, so that is ln the top minus ln the bottom. ln1, what is ln1 equals to? ln1 is equals to 0, and then you are going to subtract ln e to the 1/3, right? And then you have 0 minus, you bring the 1/3 down, and then you have ln e, and then ln e is equals to 1, so 0 minus 1/3 times 1, you have a negative 1/3. I know you have questions to ask, so ln1, what is that equal to? This is a base e, so e to the what power is equals to 1? The answer is 0 power. And then the other one, ln e, what is that equals to? So there is a base e right over here. So you are asking e to the what power is equals to e. The answer is the power is equals to 1. So that's why ln e is equals to 1, and then ln1 is equals to 0. And then I think on my notes, I prepare an extra problem for you. Yeah, on my notes, I prepare an extra problem for you. It is good to discuss that as well. I will just put the problem right over here. So we have 2 times ln e to the 8th power minus ln e to the 7th power. Just add an extra problem to you. So this one, we see an exponent, so we have to bring the 8 down. So 2 times 8 ln e, and then minus 7 times ln e. So since ln e is equals to 1, this is a 16 times 1 minus 7 times 1, that is equals to 9. Okay, that is the end of this video. If you like the way I teach properties of logarithm, give me a thumbs up, give my channel a subscribe, and I will meet you all in the next lesson for more math contents. Signing out.